Hello, my name is Cassie, and this is my 3-minute thesis on directed contact networks, or DCNs. DCNs are in the families of graph theory and topology. I'm experimenting with transportation data for my master's capstone. To modify the data, I'm using canonical topological methods taught in Topological Data Analysis 3. My first goal is to create a digraph of temporal and spatial distances linked by airplane paths and how many contacts those paths make with individual nodes. The first few steps I've taken has included finding data from the UK on all commercial transportation hubs, partitioning the data to only include airfare. Then I have converted longitude and latitude locations of airports into labeled nodes based on traffic concentration, where total sum of traffic is greatest at the beginning of the monotonic sequence and least at the end. From here, I entered a pairwise analysis of these labeled nodes using Vietoris-Rips filtration. This was to analyze the divergence of airplane paths, since the hyperbolic motion of the plane is consistent with Euclidean distance. It is represented as a dendrogram in the top right-hand corner of my slide pictured here. The longest and most persistent of these paths are going to be that straight line in the dendrogram that surpasses all the other merged points, where smaller distances are clustered around a centroid or central vital location. The temporal filtration, however, is closer to a Manhattan distance, underlying the second graph. To transition these graphs into a homologous manifold, I use Markov chains pictured at the bottom. The Markov chains are used as a transition because the consistency of the simplices that are built from the Vietoris-Rips and the temporal filtration will have some inconsistencies that are random. These inconsistencies will be known as topological holes. These result from things such as bad weather or terrorist attacks, or simply force majeure that happens that shuts down airports or creates no-fly zones. The Markov chains take all of the instances of these persistent temporary holes and predict how often they may occur in the future. Thus, the thesis is composed of a null hypothesis that flight pattern simplices will be invariant and persistent. Alternatively, I will find temporary holes that result in no-fly zones. Thank you.